Hello and welcome to another video tutorial, and in this video tutorial we are going to discuss passwords, Unix or Linux and Mac operating systems, where they stored, what are the algorithms used to protect those passwords, and any other methods they have against attacks. Traditional Unix systems keep user account information, including one-way encrypted passwords, in a text file called etc passwd. As this file is used by many tools, for example ls, to display file ownership and so on, by matching the user ID with the user's names, the file needs to be world readable. Consequently, this can be somewhat of a security risk. Another method of storing account information that's being used is the password file being changed with the shadow password format. As with the traditional method, this method stores account information in the etc password file in a compatible format. However, the password is stored as a single X, or actually it's not really stored in that file. A second file called etc shadow contains encrypted password as well as other information such as account or password expiration values and so on. The etc shadow file is readable only by the root account and is therefore less of a security risk. Most of the Linux operating systems or Linux distributions already adopted the password and the shadow file configuration. Basically, they are pre-configured to store passwords in the shadow file and user information in the passwords file. In the example below, you can see the contents of the etc password file. We have a username, which is demo, X for the password. There is the user ID, which is 1000. The user name would be demo, and additional information like phone number and so on. We also have the home directory, which is home/demo, and of course the terminal, or what is going to be loaded when the user connects over SSH, for example, to the machine. It's going to be started with bin bash, so they're going to have a born again shell access to the machine. Sometimes there are other shells that you can assign, or no shell or no login, so you have options, and you can see all these settings in the etc password file. As you can see, each view of this password entry is actually separated with a colon characters, and as I said, it follows the username, the X for the password, a numeric user ID, and of course for root that would be 1. There is the numeric group ID again, this is 1000. For root again it will be 1. There is the full name, which in our case is just demo again, and additional information as well as the shell. So when you're reading a etc password file, these are the things you can get as an information from that file. Moving to the etc shadow file, you can see we have again the username, which is up to 8 characters, and it's case sensitive, usually is all lowercase. It is a direct match of the username in the etc password file. There is a password, which is a number of characters that are encrypted, and you can see underneath that there is a breakdown with an ID, the salt, and the hashed actually entry of the password. After that, we have the number of days since the password was last changed. This is counting from the January 1st of 1970. Then we have the number of days before password might be changed again, which is 0, which means that it could be changed at any time. After that, we have the number of days after which the password must be changed, and in our case we have nines, which indicates that the user can keep this password or her password unchanged of many years. And then the number of days to warn the user of an expiry of the password, which by default is 7, it's a 1 week. And then we can have the number of days after the password expires that account will be disabled, and the number of days since the 1st of January 1970 that an account has been disabled. And of course, there is a reserved field for possible future implementations. Speaking of the actual password, the ID is actually the ID of the hashing algorithm that is used for the encryption of the password. And if the ID is 1, it is $1, which means that it's an MD5. It could be 2A, which will be bullfish. 2Y again is a bullfish deviation, and then 5 and 6, which are SHA 256 and SHA 512. Pretty strong algorithms, as you can see. Of course, without the MD5, that could be used to encrypt the password, and again with the salt, this is really hard to break. Moving on to the Mac operating systems, the MacOS X, we should first of all start with the most obvious differences from Unix implementations, which is common to all current versions of the OS X. That is that the user information is stored not in a flat files like the etc password and so on, but an actual database called netinfo. The problem is that flat files just don't scale beyond the small systems. The history of netinfo goes all the way back to NextStep and is similar in concept to the NIS from Sun and the LDAP protocol. All these non-compatible solutions store user information in a database instead of flat files to improve performance and scalability. These days, LDAP has pretty much beaten out the other two systems in the Unix enterprise, but netinfo persists on a desktop versions of the OS X, probably because it works and it's just not worth changing it at this point. Netinfo provides some nice Unix compatibility features. One example is the command to dump the netinfo user database in a standard Unix etc password file, for example, which is nidump passwd. However, there are some differences between different OS X versions. In OS X 10.2 and presumably 10.0 and 10.1, the hash password is stored directly in netinfo. It also uses the standard Unix DES hash. Since all users have access to the complete netinfo database, any user on the machine may run the nidump command and get every user's hash's DES passwords. The DES encryption algorithm has proven to be actually weak in the 1997 by RSA DES challenge, and DES also truncates password to 8 characters, which makes it nearly impossible to use a passphrase instead of a password. Fortunately, in 2003, Apple released OS X 10.3, which attempted to fix these issues. First and foremost, passwords are now shadowed and stored completely outside of the netinfo. Now, when a non-privileged user tries to dump the netinfo user database, they no longer get the password. Rather than use a standard etc shadow file or hashes, they are stored in a var db shadow hash directory like etc shadow. This is readable only by root. However, each user's password is stored in their own file. The file is not the username of the account, but the generated UID in the netinfo field. However, OS X version 10.3 also lacks salts. All these weaknesses are addressed in the version of the OS X 10.4. They added salt and also updated the algorithm used for the encryption. They also added a warning for a landman password, and of course added support for these passwords only when Windows shares are involved. In OS X 10.8 or Mountain and 10.9 the Mavericks, and of course 10.10 Yosemite, the shadow files are stored on the file system at the var db ds local nodes default users, and then a user as a variable .plist. They are in plist format, so you will need to use the plutil command to view them, or use the default command to extract write specific keys if desired. Only the root user has access to these files. To view the contents of the shadow file, for a user, you should use the sudo plutil command. Thank you very much for watching this video. I hope you found something interesting and something new. And of course, as always, I hope you learned something. And if you like the video, hit the likes button, subscribe for more videos, and I'll catch you in the next one. Thank you very much, and goodbye.